doing? Welcome to another edition of Precalculus via Patio Productions. One of my favorite things to do. We're going to move on to the next section of lessons today, and hopefully you were able to print out the notes, fill-in notes for today. Just makes things a little bit easier. Okay, so this guy right here says 13.5, and so that's the one you're going to want to have printed out, and let's get started. It might be a good idea to have a calculator with you just because some of the numbers, we're going to have to be multiplying some numbers. So if you want to go fetch that while I'm switching over, that would be a great idea. So let's go ahead and get this PowerPoint up and running, my beautiful friends. Okay, how's it going out there? Is it going well? Are you doing great things? I hope so. I hope so. The beginning of this lesson, I went ahead and just again posted step 3 of all the ones from the previous night's homework on math induction. So I'm just going to just kind of scroll through here on each one of these. If you wanted to pause at any moment to work on these babies, then that's fine. There was also the PDF that you could consult. So all of these different guys ready to help you out there, all the different types. Just step 3 though, because I felt like the other parts were pretty standard. Okay, and here we go, the binomial theorem. So here is our topic of the day. It's called the binomial theorem. So basically, I know we've done this in class before. You know how like if you just have something like, let me actually grab my pencil-y guy right here. Dun, 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 dun. Okay, if you have something like x plus 3, if I can make a 3, and then quantity squared. Don't we have kind of like I don't want to say a cheating way, but like a streamlined way to do this where you don't have to write x plus 3 twice? It's like the first term, you just put x squared, and then it's 2 times 3 times x, and then it's so 6x, and then plus 9 for 3 squared. You are actually doing, and you didn't even know it, you're actually doing a very simple version of the binomial expansion theorem. Like, who knew, right? Like, amazing. Yeah, totally. And so what we're going to do now is be able to expand bigger things to any power that we want to, okay? So there's several theorems and strategies that allow us to expand these guys. So something like x plus y to the 4th power. Okay, notice that the title of the lesson was the binomial expansion, right? So this is a binomial, guys, and then we're raising it to a power, okay? This is a binomial, and we're raising it to a power, okay? So what happens is one of these ways, there's actually 2 different ways, and we're going to learn how to do both of them because really I should just arm you, like, right? Like, with as much things as we can, okay, so that you can just choose which way you want to do it. So one of the ways is called Pascal's triangle, and I'm pretty sure you've been exposed to Pascal's triangle before. Pascal's triangle is already on your paper, but it starts with a 1, and then it goes a little bit diagonal and has a 1 and a 1. Then each row starts and ends with a 1, okay? And then to get each term, and you're going to be adding of these. I'm sorry, not adding. Just kidding. Let me say that again. You'll be writing this stuff in your notes, okay? So you're going to get each term, and to get each term, the whole team is working today. You are going to add the 2 numbers diagonally above that spot, okay? So you start with a 1, and then you add the 1 and the 1 to get 2, and then you end with a 1, and then there's like all these spaces. So you can sort of illustrate this on your note paper if you want to. Okay, then you start with a 1, you add 1 and 2 and you get 3, you add 2 and 1 and you get 3, and then you end with a 1. Let's do one more row. Okay, you start with a 1, you add 1 and 3 and you get 4, you add 3 and 3 and you get 6, you add 3 and 1 and you get 4, and you end with a 1. Go ahead and do the last one yourself. So I'll give you like just a minute. I'll give you a drum roll worth. Did you get this for your row? 1, 5, 10, 10, 5, and 1. Okay, so this goes on forever. You can do this forever and ever and ever. Let's give you one more drum roll. One more. Did you get this? 1, 6, 15, 20, 15, 6, and 1. And that's what it is, okay? So you can keep going forever and ever and ever, and it just will get wider and wider and wider and wider, and it's kind of like super amazing. Okay, so let's get back in here. Okay. And so another idea to get each of the, Mrs. Fox, why were we even doing this? Okay. So first off, these numbers are going to be the coefficients that go in front of each term, meaning that if you're raising something like to the fourth power, like the example at the top, the 1, the 4, the 6, the 4, and the 2 will be your coefficients of each of the terms when you expand it, and you don't have to actually like write this guy out. Like you don't have to write x plus y 4 times, which would be like super boring. We do not even want to do that. Okay, so the other idea to get the numbers, and this actually comes in handy, like Pascal's triangle is nice, but it's kind of big and cumbersome. So if I'm going to like, I don't know, the 4th, the 5th, or the 6th, I am so busting out the gorgeous Pascal's triangle. However, okay, if you're like, if they ask you to raise something to like the 30th, no. That is so not an idea that we should be using the Pascal's triangle for. Instead, we'll go ahead and we'll just figure out maybe like a couple of terms by doing factorials, okay? So do you remember back in the day that 5 factorial means 5 times 4 times 3 times 2 times 1. That's what being a factorial means, okay? If we had n factorial, it would be n and then times n minus 1 because it would be 1, the term 1 less than it, and then n minus 2, the term 2 less than the starting number, plus however many you have, whatever n is, and then times 2 times 1, okay? So this is amazing things that we can use instead of Pascal's triangle, okay? So do you remember this also, NCR? This was like notation that you could put in your calculator, right? You were able to put a number and then you go to the probability menu and you choose NCR and then you put another number. That equaled out to be n factorial over subtract the numbers n minus r factorial times r factorial. And each of these actually can also be written this way as n per, it's kind of like a tall parentheses, and you write the n and the r on top of each other. It means the same thing, okay? It's just a way to get some numbers, but if I'm doing these in on my own, I'm going to probably use that NCR button on my calculator because I think that that's actually like pretty handy. Okay, so the next examples say find the lie and fix it. So we're playing true truths and a lie. No reason to not play true truths and a lie. And so I'm going to give you a couple drum rolls to go ahead and just calculate these in your calculator. Remembering that for part B and part C, you should probably, for both of these right here, you should probably be using the NCR notation in your calculator to see if it works. So let's give you like 2 drum rolls, and then we'll see if that was enough time for you to figure out which one was the lie. So here's one roll, drum roll. Another drum roll. Doesn't have the same without the ta-da. Here we go, one more. And hopefully in your calculator, you were able to figure out that A was correct, B was correct, but C was not correct. Okay, the answer was supposed to be 4,368. So hopefully you were uber successful, right? Everybody did a great job on that, and we were trying to just see what which one was the lie. So now I would like to explain a connection between Pascal's triangle and then that NCR, or like the N choose R sort of like idea and notation. If you were to take an instance just like row 4, okay, so this is row 4 right here. I just pulled it from the top of my paper. This is row 4. The numbers were 1, 4, 6, 4, and 1. Oh, side note. How do you know what row it is? The row is always the second number in, because you know how the numbers, every row starts with a 1. So to figure out what row you're on, you go to the second number, and then that's what row you are, which means actually it starts on the top when there's just the 1. It's actually row 0, then row 1, then row 2, 3, 4, 5, etc. So that was like total side note, but fun to know. Okay, so I want you to notice that actually 1 is 4, choose 0. 4 is 4, choose 1. 6 is 4, choose 2. 4 is 4, choose 3. And 1 is 4, choose 4. Why don't you go ahead and take any of those any of these choose, guys, just pick one of them. It doesn't even matter. If we were in class, we like divide and conquer. But go ahead and just choose one of these to put in your calculator using, right, the NCR button. And go ahead and put that in your calculator and see if you can actually get the right number on top. You'll get a drum roll. I'm sure it came out to be the right thing because I know that it works. Yay! Okay, so this notation will help us expand binomials if we really don't want to do Pascal's triangle, as well as, and this is probably the most important part, like what we're definitely going to use it, finding a particular term, okay, of an expansion without expanding the whole thing. That is definitely what we're going to be using this for, okay, like 100%, 100%. So the way that we expand a binomial, now, honestly, I feel like there's a couple of like different ways that you can do this, just kind of like your preference. Some people like to do one term at a time. I am of I like to do, this is just me personally, I like to write out all my coefficients, and then I do all the powers of the first guy, like this guy right here, and then I do all the powers of the second guy. Some people like to do it all the way, like do what you want to do, right? Like it's your paper, so you do what you're most comfortable with. Just get the right answer, right? And then always there might be some simplification that we might have to do. Okay, so we're going to figure out what the coefficients are using Pascal's triangle or the n choose r method, whichever you want. Like honestly, guys, seriously, it's your choice, right? I know sometimes there's choices in mathematics, like not always, but like yeah, totally there is sometimes. Okay. And then you have to do the powers of each variable. So the powers of the first term are going to descend. Like for instance, if this happens to be a 4, like if this n right here was a 4, we'd have the a guy to the 4th, and then we would have to the 3rd, to the 2nd, to the 1st, and then to the 0. Did I do that right? 4, 3, 2, 1, 0. Yes, I did. Okay. Then the powers, so that goes from n to 0. Whatever the number is. And then the powers on the second term are going to ascend. So they're actually going to start with 0 and then go to 1. So if I'm looking at this B guy right here, right, the B guy would start with B to the 0 and then go 0, 1, 2, 3, 4. Okay. And again, there's going to be 5 terms. So that's another fun little note. Total side note. Like, look at me giving you extra stuff. Okay. Side note, whatever the power is. So say like it was a 4. It's a good one to grab onto. There's, how many terms are there? 1 more than the power. So if it happened to be to the 10th, you would need 11 terms. I don't have any extra fingers. So I'll just give it elbow too. So there'd be 11 terms, right? Okay. So it's always 1 more, and then you can almost like sort of keep track for yourself and just make sure things are ending up where they're supposed to. The first guy would go like to the, say we're doing to the 10th. So 10, 11, 12, 10, 11, 12. We're just sending in order. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then the other one would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just like that. Okay, let's give, oh, we got to turn the page. What's our, oh, I need a new sound for turning the page. So I'm going to do this one. Turn the page. Here we go. We're going to do only examples on the back. So all these are examples, and there are 1, 2, 3, 4, 5, 6 different kinds. Okay, 6 different examples. They're all just a teensy little bit different. Okay, so you can see the breadth of questions that we can ask you because the concept for today is actually pretty straightforward. Okay, so using Pascal's triangle, we're going to expand this guy to the 4th power, nice and easy and smooth and gorgeous. So this is like how Mrs. Fox likes to do it. I like to write down my coefficients first. So if I look at, I'm probably going to use Pascal's triangle. I'm going to consult Pascal's triangle, row 4 right here on my paper. I'm looking at my paper. It says 1, 4, 6, 4, and 1. I'm going to write those coefficients, and they all have plus signs in front of them. So 1, and then 4, and then 6, and then 4, and then 1. There are, in fact, 1, 2, 3, 4, 5 terms. Okay. Then what I'm going to do is I'm going to take my x power and I'm going to write x in parentheses. Oh my goodness, you guys, it is so important that you put your all of your variables, whatever it might happen to be, you have to put them in parentheses. Okay. So I'm going to do an x to the 4th. I don't even put it in parentheses. Oh my goodness. Okay, don't do what I did. Go ahead and put that in parentheses. Okay, the reason why I'm saying put them in parentheses is sometimes, I mean, this one actually is not necessary, but this one right here just says X, but what if it said 2X or like negative 2X? I would definitely need to put it in parentheses. So I guess I'm letting it slide this time. Okay, not a big deal. Okay, so we have x to the fourth, x to the third, then x squared, then x to the first, and then x to the 0. Go ahead and write it down because it's going to keep you on track. Okay, then I'm going to go back through the question. I'm going to write, not the question, the expression, and then I'm going to put the y's. So y to the 0, and then this one's going up. Y to the first, y to the second, y to the third, and y to the fourth. You would clean this up if you needed to. Now, this one's pretty basic. You're not raising any other numbers to the powers. It's just an x and just a y. So probably the only thing that I would do is get rid of the guys to the 0 power. So this guy right here is going to go away, and then this guy's going to go away. And then I usually don't write a coefficient of 1. So really, the best answer for this is going to be x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth, and that's going to be our beautiful answer. Doesn't that look nice? Like, it's pretty cool looking. Okay, let's do another one. And so this one I made a little bit more complicated, and I'm definitely going to be using parentheses, okay? The first term is actually an entire 2x. The second term, guys, you got to be really careful, is a negative y squared. You got to be really careful that you cannot lose this negative right here. And then we're raising this baby to, in fact, the 5th power. Okay, so here we go. The way that Mrs. Fox likes to do it, she likes to go through the question 3 times, like 3 sweeps almost, okay? Like sweep, sweep, sweep. And first I start with the coefficients. I'm going to look back at my Pascal's triangle. Just let me turn my paper over really fast. Yep, got it. The ones that I wrote down. Turn it back. And let's go ahead and write down the coefficients. So the coefficients were 1, 5, 10, 10, 5, and 1. And I'm spreading this out so that I have enough room to raise all my guys to the powers. And then I'll clean it up with my calculator. It'll be so great. Okay, so I did my first sweep, whoosh, and I'm now going to do the 2x to the power. So I'm going to do a 2x to the 5th, and then a 2x to the 4th, a 2x to the 3rd. Notice the parentheses. So much prettier. Okay, a 2x squared, a 2x to the 1st, and a 2x to the 0. Then I'm going to pass by one more time. I'm going to put a negative y squared to the 0, negative y squared to the 1st, negative y squared squared, negative y squared to the 3rd, negative y squared to the 4th, and negative y squared to the 5th. Okay, I'll just give you 1 second to catch back up. I was going a little bit quickly, like, woo, super fast, Mrs. Fox. Okay, guys, and now I'm going to clean. Okay, so now I don't get to leave it like this. I need to actually like get rid of all the parentheses and tidy up my terms. So you have to remember that, especially like on this first term, guys, we're actually raising the 2 to the 5th and the x to the 5th. And then this guy is going to go to the 0 power and go away. So 2 to the 5th happens to be 32. So this is going to be the first term is a 32x to the 5th. Now, on this one, we have to be careful. We have to take this 2 to the 4th power, then multiply by 5, and then multiply by -1 because this guy is to the 1st power. Okay, a 2 to the 4th is 16. 16 times 5 is 80, and then the -1. So negative 80 x to the 4th y squared. The next term would be 2 to the 3rd, which is an 8. P.S. I can use my calculator. I'm just doing it in my head, but totally use a calculator because sometimes the numbers are kind of big. That would be an 8 times 10, and then times a +1 because -1 squared is positive. So that's a plus 80, and then x to the 3rd, and then y to the 4th because you're raising a y squared to the squared. So that's a y to the 4th. Over here, the 2 squared is 4. 4 times 10 is 40, and then a -1 is going to give us a -40, and then x squared and y to the 6th. The 5th term of this guy would just be 5 times 2 times a +1, so 5x and y to the 8th. And last but not least, this 2x to the 0, whoosh, is going to go away. And then we just get a minus a y to the 10th. And that is your gorgeous answer. Isn't that nice? Nice and fun. Okay, let's try the fourth example. So now it's not asking us to expand the whole thing, okay? We are not expanding the whole thing. Okay, imagine if I was. This guy is to the 11th power. Are you kidding me, Mrs. Fox? Okay, you are trying to tell me that I would have to do like find the Pascal's triangle, the 11th row. Okay, no, not at all. Instead, we're just going to find one of the terms. It's not asking us for the whole thing. It just says find the coefficient of the indicated term and identify the missing exponent. So let's go find just that term. Okay, we have just x to the first power and just y to the first power, and we're raising it to the 11th. Okay, what I like to do is, I don't know if you've noticed something, but I'm going to go backwards, just like one example, super duper quick. Okay, did you notice on this first example right here that when we were raising it to the fourth power right here, okay, the fourth power, that the exponent numbers added to the fourth, like 3 plus 1 was 4, 2 plus 2 is 4, 1 plus 3 is 4, 4 plus 0 is 4. Okay, so all of that, that's funny that the writing is still on there. Let me get this all put back where we were, guys. Okay, so everything adds up to what the power is, okay? Well, the total power that we're raising. So we already have that this is a 9 right here. So what would be missing on the x to go ahead and add up to an 11? It would just be a 2. Okay, so we now know that we are going to have an x to the squared power and then a y to the 9th power. But now we need to figure out the coefficient. Okay, so it's actually really easy. What you can do is just take your 11 factorial over each one of these exponents factorial. So that's what the coefficient's going to be. It's actually just going to be 11 factorial over 2 factorial, 9 factorial. So one more time, Mrs. Fox, where in the world are you getting those numbers from? Okay, let me help you. So to find the coefficient, right? So we're working on the coefficient right here. The coefficient is going to be the power factorial divided by each of these powers factorial. So 2 factorial and 9 factorial. So that's why I like to do the exponents first and then figure out what the coefficient's going to be. You have to be really careful putting this in your calculator. Okay, guys? When you put it in your calculator, you're going to do 11 factorial divided by, and then you're going to make a parentheses, 2 factorial, 9 factorial, and then close the parentheses. Mrs. Fox, where is that factorial button? Remember, the factorial button's in that probability menu where we were doing the NCR, all right? And then it's totally right there. You're going to put this in your calculator. Do not forget to put the parentheses. Okay, you should have got 55. If you did not get 55, whoopsies, you probably forgot to do parentheses around the bottom, okay? So always do the parentheses around the denominator, and then that is our answer, 55x squared y to the 9th. Gorgeous, look at that. So fun. Okay, we are jamming along on our examples here. We're on example number 5. This guy says, find the term involving the specified value. So we're wanting the one that has b to the 6th in it. Okay, so it's actually just a slightly, only a teensy little bit, just a teensy, slightly more difficult question than the one before. So if we have a b to the 6th, what does that mean that a is going to be to? Okay, so if you have, P.S., it is a negative b to the 6th. Look right here, guys. You see how this says negative b? So it's going to be a negative b to the 6th power. And then what would add up to be 14? This number up here for the power for a would have to be an 8. Okay, and then how do I get the coefficient in the front? The coefficient is going to be, we just learned how to do it. You're going to do 14 factorial and then divide by 8 factorial and 6 factorial. Okay, this baby right here is going to go in your calculator. Remember to put parentheses around the denominator. This guy right here is going to be a negative 1 to the 6, so it is going to turn out to be a positive number. Okay, putting this in your calculator, you get a 3003, and then we have a to the 8th and b to the 6th, just like that. So fun. Guys, we're doing such a good job. Okay, now this one says find the indicated term. Now on this one, I'm going to be honest with you. I like to just count it out on my fingers. I think it just kind of makes sense. So what I like to do is I like to set up the bare bones of what it's going to look like. Okay, so I like to do this. I like to have like an a to a power, the 5b to a power, and then I have a space for the coefficient. And I think that that always works kind of well. Where's my little drawing guy? Guys, I always keep losing it. Let's just draw on the paper. Oh, there it is right there. Let me undo that. Just kidding. Erase that. My bad, my bad, my bad. Okay, so here we go. Sorry, I got a little mixed up. Okay, so we're going to do an a to the square. Now, why is it a squared? Why does that work? Okay, so here's how it works. If there are four, if this is being raised to the fourth, you know you're going to have 5 terms, right? And if you wanted to have an a squared, if you count the first term, okay, you know it's going to be a to the fourth, and then it's going to be a to the third, and then it's going to have a squared. So you would count down, and we're now talking about this third term, okay? So the third term, right, there's 5 terms, okay, 5 terms. Let me just put my hand up here right here. There's 5 terms. The third term, you would start by the first term would be an a. Which way would that be to you guys? I don't know how you can see it. Oh, probably over here. So this would be an a to the fourth, an a to the third, and then an a squared. So that's why it's an a squared, okay? What would it be for the other power? Well, 2 plus 2 would make 4. And then how do we make our coefficient? In front of the question, you put your 4 factorial over 2 factorial, 2 factorial. Okay, just like that. Looks very pretty. And now we'll go ahead and simplify. So remember, this is going to go in our calculator, remembering to put parentheses, okay, around the denominator. And then also we have to remember to multiply to the 5, bring that 5 to the squared power. So we have to do 2 things here. So 4 factorial over 2 factorial is just 6. Then we're going to have an a squared and then 25b squared. We clean that up just a little bit and we get 150, okay, a squared, b squared. And then let's do another one. So this says the 4th term, okay? So there is going to be 12 terms of this. If we're starting with the 11th power, okay, it's going to be a 2a and then a negative 6b. We're going to have each of those guys being raised to the powers, and let's count it down. So we're going to do the 4th term. So I'm going to hold up 4 fingers, okay? I'm holding up 4 fingers, and 2a first would be to the 11th, then the 10th, then the 9th, then the 8th. Can you do it with me? Let's do it one more time, okay? So put up your 4 fingers. If you didn't do it the first time, do it with me now. 4 fingers. 2a is going to start out. The first term is to the 11th, then the 10th, then the 9th, then the 8th. And so we are going to have 2a, right? We're raising 2a to the 8th. And then what would negative 6b be raised to? Well, it has to add up to be 11. And so that would be it to the 3rd power. And then our coefficient in the front is going to be 11 factorial over 8 factorial, 3 factorial. This number is going to get kind of big. So good thing that you have your calculator. Like, yes, I grabbed my calculator. Okay. So first of all, we're going to put this in our calculator to do the coefficient. And then we're going to raise some stuff to the powers. So in my calculator, 11 factorial divided by 8 factorial, 3 factorial is 165. A 2 to the 8th power is actually 256, a to the 8th. And then negative 6 to the 3rd power is negative 216, b to the 3rd. I then go ahead and clean this up by multiplying all 3 of my numbers here, all 3 of these constants. In my calculator, I do 165 times 256 and then times negative 216. And I get the very large number of 9,123,840. It's negative a to the 8th and b to the 3rd. Look at that. That's it, guys. So that brings us to the end of our lesson. Oh, I love this meme. We have to look at it. Look, it's instead of Pascal's triangles, Pascat's triangle. So funny, so cute. Okay, guys, here's your assignment. You're going to do page 712. I think the answers, the questions are pretty straightforward. I think it's going to be a much easier time than yesterday's lesson on the math induction. If you still need to practice math induction, my goodness, guys, please, please, please practice your math induction. Okay. That is definitely one of the harder topics. And so I think that's it. So I hope you guys have a lovely rest of your day. Enjoy doing your homework. Come visit me in office hours if you need to. And let's send us out with our fanfare. Bye, guys. See you later.